Hi all the students. Today we are going to study about the protocol hierarchies in a network. So basically to reduce the design complexity. Now the network will have a certain design. So in order to reduce the complexity of the network design, what is done is that the network is designed in a modular manner. So what do? We give a modular design to the network where we provide separate modules for separate tasks, right? Each module, the entire large network will be divided into separate small modules, wherein each module will be provided with an individual or specific task, and this way the complexity of the design is reduced. The most important task of having a modular network is to reduce the complexity of the design. So basically what we are doing, we are reducing the complexity of the network design by breaking it down into various modules where we provide each module with a separate task, right? Now imagine a situation where in a class I say that okay, all of you are responsible for checking the neatness and cleanliness of the class. At the same time, you are responsible for checking who is wearing the uniform properly. At the same time, you are supposed to check who is disturbing the class, and you also have to check that who is not doing their assignments on time. Now so many tasks collectively I give to the entire class at the same time. So this becomes a little complex because now you do not know, there is no person designated as such for a specific task. So if for example the assignments are not given on time, how do I know that which person should I call for finding out that why the assignments were not given in time? Because there is no specific person to who I gave this responsibility. I gave this responsibility to the entire class. So now the accountability for this particular task is less because it is for the entire class, and I cannot figure out who to call when the assignment is not given on time, because there is no specific task assigned to a specific group of people. Entire class is doing everything, so it's quite complex. But if I divide the class into groups of 4 or 5 people, and each group is assigned a specific task, wherein one group is assigned the task of finding out the neatness and cleanliness of the class, other group is assigned the task of finding out if the assignments are not given on time, the other group is responsible for checking keeping a check on the people who disturb the class, and similarly the other group is there for checking if the people are in proper uniform, the students are in proper uniform or not. So this way, for example, if there are certain students who are not in proper uniform, I know which group I should ask for. I will call that particular group and try to find out why these students are not in proper uniform, because I know who is accountable for what now. So similarly, so that means this is a modular approach. I have divided the class into modules or groups of 4 people, and each group is assigned a specific task. Similarly, here in case of network design, what I do is that I divide the network into layers or modules. These modules are what? These modules are the layers. So I divide the network into modules or layers, wherein each module or each layer has a specific task to do. So I know if there is a problem at a particular point of time, then which layer should be checked for that particular problem, the kind of problem, so that kind of layer should be checked for it. So the design complexity is reduced in this way. Now each layer here, each layer is responsible for providing certain services. Each layer or each module is providing certain services, right? Services to who? To the higher layers or to the layer above it. If I show it through a diagram, see, for example, this is one layer, this is another layer. I have suppose 5 layers. So like this, I have 5 layers on one host. Layer 1, layer 2, layer 3, layer 4 and layer 5. Right? This is on one host, which I call host 1. Similarly, I have 5 different layers on host 2 also. So layer 1, layer 2, layer 3, layer 4 and layer 5. So these are different layers. These are 5 different layers on host 2. So layer 1, layer 2, layer 3, layer 4 and layer 5. Right? Now the layers on the same level are known as pairs. Right? So these are known as pairs, and the layers on the same level or the peer layers can only communicate with each other. And as I told you in my previous video, there are some protocols for communication. So every layer will communicate as per the protocols. So layer 5 protocol, layer 5 on host 1 wants to communicate with layer 5 on host 2, there are protocols for layer 5. Similarly, there would be protocols for the layer 4 on both the hosts for communication, known as layer 4 protocol. Similarly, for the third layer, known as your layer 3 protocol, and similarly then for the layer 2 and for layer 1. So this means that only the pair layers can communicate with each other, and at each layer there are protocols for the communication of the pair layers. Now layer 1 or the layer below always passes the services, provides services to the layer above it. So layer 1 will provide its services to layer 2 on host 1. Layer 2 will provide services to layer 3 on host 1. Layer 3 will provide services to layer 4, and 4 will provide services to layer 5 on host 1. Similarly, in case of host 2 also, layer 1 will provide services to layer 2, L2 to L3, L3 to L4, L4 to L5. So this is how the layers communicate with each other. While layer 1 is providing its services to layer 2, it will hide how those services are being provided. So this is known as information hiding. You always hide how the services are provided. You just provide with these services, and this concept is used throughout the computer science. Right? So what is layer 1 doing? Whether it is on host 1 or host 2, layer 1 is providing services to layer 2, but the details of the internal state and the algorithms that are used for providing the services are hidden from the layers above it. They just provide the services, but how those services are provided are hidden, right? And so for all the layers like layer 5 on host 1 and host 2, layer 4 for host 1 and host 2, these are peer layers which can directly communicate with each other, right? Protocol, I have already told you that what a protocol is. A protocol is nothing but basically the set of rules. A protocol is the set of rules which are used for communication. So as I told you in my previous video also, that what is a protocol? Protocol is the set of rules or an agreement between the communicating parties, that how the communication will proceed, and then both the parties will then adhere to the same protocols for communication, right? Okay, now basically in reality no data is directly transferred from layer n on one machine to layer n on other machine. No data is directly transferred. So how is the data transferred from layers on one machine to the layers on another machine? Again, I will draw the same diagram and tell you. So these are my 5 different layers on 2 different machines or 2 different hosts. These are 5 layers on host 1, and then I have 5 layers again on host 2, like this. So these layers I call layer L1 or layer 1, layer 2, layer 3, layer 4, layer 5. Then again on host 2 also I call them layer 1, layer 2, layer 3, layer 4 and layer 5, right? H1 and H2 here mean host 1 and host 2. Then we have protocols. So these dashed lines are basically representing virtual communication. Dashed lines represent virtual communication between the peer layers. So layer 5 communicates on host 1, communicates with layer 5 on host 2. Similarly, layer 4 on host 1 communicates with layer 4 on host 2 and so on. So layer n on one machine can communicate directly with layer n on another machine. So then you have protocols like this for all the layers. The layer 5 protocol, then layer 4 protocol, then layer 3 protocol, layer 2 protocol and layer 1 protocol for communication between the peer layers. So this is the virtual communication that we are talking about, the virtual between the peer layers. But actually physically how the communication is taking place between layers on one machine and then it is passed on to another machine. How this happens, let us see. So what happens is that when I say pairs, these pair layers, these could be anything. They could be your processes. That means a pair could comprise, when I say pair layers, so pair could comprise of anything which may include your processes, which may include your hardware devices, or which may include your even human beings. It could be even human beings. So by peer I mean any processors or hardware devices or your human beings. So peers may be it is the peers, as I told you, that communicate directly using the peer, protocols, but in reality, as I told you, no data is directly transferred through layer on one machine to the layer on another machine, right? What happens is that each layer passes data and control information to the layer immediately below it. So layer 5 will pass the layer 5 passes data and control information to layer 4, right? Layer 5 on host 1 will pass data and control information to layer 4. So data is provided and then control information tells you what to do with that data. What is control information telling you? What to do with that data. Just passing the data alone is not enough. You should also tell what has to be done with that data. Like for example, if I give you two numbers 2 plus 2 and I do not tell you what to do with it, how will you know what to do? I need to tell you whether you have to add them or subtract them or multiply them. So here 2 and 2 will be your data, and whether you are supposed to add them or subtract them or multiply them will be your control information. So this is what a layer 5 does. It passes data as well as control information to the layer 4 so that it gets the data as well as it knows what to do with that data. So always layer above passes data and control information to the layer below it, and the layer below provides back services to the layer above it, right? So basically, precisely speaking, upper layer, the layer which is above, upper layer provides data plus control information to the layer below, provides data and control information to the layer below. And lower layer, what does lower layer do? Lower layer provides services to the layer above it without telling how those services are provided. So this is how actually the physical communication takes place, right? And this keeps on happening until the lowest layer is reached. Like the data and control information will be passed from layer 5 to layer 4, then from layer 4 to 3, then from 3 to 2, and finally from 2 to 1. So until and unless the lowest layer is reached, this will keep on, the data and control information will keep on passing down. Now below layer 1 is the physical medium. Now you would ask, what after it reaches the lowest layer? So after the lowest layer, after the layer 1 is your actual physical medium through which the data will be transmitted. So that means the transmission channel we are talking about. Below layer 1 is your physical medium. So layer 1 finally transmits the data to the physical medium, and then through the physical medium it is passed on to layer 1 on host 2, then finally from layer 1 on host 2 to layer 2, then to layer 3, then to layer 4, and finally to layer 5, right? So this is how the actual communication takes place. So that is why the virtual communication, these dotted lines show your virtual communication, and these solid lines show your physical or actual communication, right? So between each pair of adjacent layers, now these are adjacent layers on the same machine. So between each pair of adjacent layers, there is an interface. So this is what you call the interface. Like this is the interface between layer 5 and layer 4. So you call this layer 4-5 interface. Then this is your layer 3-4 interface. Then this is your layer 2 and layer 3 interface. Then this is your layer 1 and 2 interface, right? And similarly for the layers on host 2 also. Now what is an interface? Let me tell you that an interface, now you would know, want to know what is an interface. So what is an interface? An interface is nothing but basically it defines, what does an interface define? It defines the which primitives operations, which primitive operations and services the lower layer makes available to the layer above it, right? So the interface between layer 4 and 5, the interface between layer 4 and 5 will tell that what primitive operations and services layer 4 will provide to layer 5. Similarly, interface between layer 3 and 4 tells what primitive operations and services layer 3 will provide to layer 4. Similarly, the interface between layer 3 and 2 tells what primitive operations and services layer 2 will provide to layer 3, and the interface between layer 1 and 2 tells what primitive operations and services layer 1 will provide to layer 2, right? So it is very important to have clean interfaces between layers. So this star means a very important thing. So it is important to have clean interfaces between the layers, because it is very important to have a clear idea of what all primitive operations and services a layer will be providing to the layer which is immediately above it, right? And the amount of information that is passed between layers should also be minimized to make the design simpler and less complex. So these set of layers, and protocols for communication between the layers, these set of layers and protocols is called network architecture, right? So next time when somebody asks you what a network architecture is, you must know that it is nothing but the set of layers and protocols for communication between these layers. So that is why we also say that our network architecture is a layered architecture, right? And similarly, the list of protocols. There are protocols for communication between layer 5 on different machines. There are protocols for communication for layer 3 on different machines. There are protocols for communication between layer 4 and different machines. Similarly, between layer 2, different protocols, between layer 1 on different between layer 1s on two machines, different protocols. So all these list of protocols, the list of protocols used by a certain system, one protocol per layer. You saw in the diagram there was a protocol for each layer, like communication protocol for layer 5, then for layer 4, for 3, 2. So one protocol per layer is called your protocol stack. So what is protocol stack? All the list of protocols used by a certain system, one protocol per layer is called the protocol stack. So if I look at this diagram again, the layer 5 protocol, layer 4 protocol, layer 3 protocol, layer 2 protocol and layer 1 protocol, all of them together would be known as my protocol stack, right? And all these layers and this protocol stack together is my network architecture.